Hello student, thank you for joining me today. Today we are going to look at uh, one of the acid-base concept-based problem, which was shared by one of my students from New York University. So the question is asking for the given pair of a compounds, identify the more acidic compound without using pKa table. So when we decide, or when we have to decide the acidity based without using pKa table, we specifically draw the conjugate bases of these compounds. And as per the stability of a conjugate base, more stable the conjugate base, stronger is going to be the respective acid. So let's draw a conjugate base of this. Conjugate base can be drawn by removing proton from O. That will give me this alkoxide ion. And a conjugate base of this thiol can be drawn by removing that proton and putting negative charge on that sulfur. So among these two conjugate bases, whichever is going to be more stable will decide the stronger acid. So to define the stability of conjugate base, we specifically use the concept ARIO, atom, resonance, inductive effect, and orbitals. This is very well described in uh, David Klein's textbooks. I'm also referring to that. So uh, if you want, you can actually read through that. So in this particular problem, we are going to discuss only atoms related. So if the conjugate base is involved with resonance, inductive, and orbitals, we will talk about the effect of these different kinds of effect in some other problem. But in this problem, we are going to use atoms to describe the stability of a conjugate base. When two atoms, we want to discuss with the stability of that conjugate base, and these two atoms have a negative charge specifically on in the same column or same row, then in that case we have to use different logics here. If the two comparing atoms where the negative charge is there in the conjugate base are from same column, then decide the or talk about the size, compare the size. Bigger the atom carrying a negative charge, more dispersed that negative charge will be, and that's why it will be more stable. Here, the electronegativity, particularly, not inductive effect, but specifically electronegativity doesn't play a role much. On the other hand, if the two atoms carrying a negative charge in the conjugate base are from same row, then in that case, we are talking about same row in a periodic table. Then in that case, compare the electronegativity. More the electronegative atom, better is the stability of that conjugate base. Now, when we are looking at these two conjugate bases, the negative charge is on oxygen, and here the negative charge is on sulfur. So, oxygen and sulfur falls into same column of the periodic table, and that's why we will discuss the stability based on size. We know as sulfur is bigger in size as compared to the oxygen, so the negative charge on a sulfur here will be well dispersed on a larger surface area, and that's why this conjugate base will be more stable. As this conjugate base is more stable, we can say the respective conjugate acid will be stronger acid. Now, if we look at specific pKa's, just to compare whether our logic works or not, we can compare with the pKa's. pKa of alcohols is somewhere around 15 to 16, whereas pKa of thiol is somewhere around 10. So definitely our logic is clearly working. So weaker acid. And likewise, you can decide the stability of a conjugate base, and based on that, you can decide the stronger or weaker acid. Like atoms, you can also talk about the resonance, inductive effect, and orbital. Whichever effect is helping to stabilize the conjugate base will decide the stronger acid. More the stable conjugate base, stronger is going to be the acid. So rest of the other effects, as I said, we can discuss in some other problem. I'll take some of the problems from my other students and then we can discuss the individual effects as well in coming videos. Thank you for joining me today. If you have any questions, concerns, or if you want to cover any of the topic, any particular question, if you have, please share with me in a comment and I'll try my best to answer those. Thank you so much.